Welcome back to section 6.1, Understanding Quadratic Functions, part 2. In our last video, we graphed parabolas that opened up. In this video, we're going to be graphing parabolas that opens down. Let's go ahead and look at explain 2a. Graph the function. Afterwards, state the domain and range. We have g of x equals negative 2x squared. I want to start the problem by making a table. Y equals negative 2x squared. And I want to include my third column because that's where I'm going to write out my points. For my x values, I want to use negative 2, negative 1, 0, 1, 2. Let's plug in negative 2. When x equals negative 2, y will equal negative 2 times 2 squared, which is negative 2 times 4, and that's going to give us negative 8. Our first point is negative 2 comma negative 8. When x equals negative 1, y will equal negative 2 times negative 1 squared. Negative 1 squared is 1. Negative 2 times 1 is negative 2. Our second point is negative 1 comma negative 2. When x equals 0, y will equal negative 2 times 0 squared. That's negative 2 times 0, which gives us 0. Our third point is at 0, comma 0. When x equals 1, y will equal negative 2 times 1 squared, which is negative 2 times 1, and that's going to give us negative 2. Our fourth point is 1 comma negative 2. Finally, when x equals 2, y will equal negative 2 times 2 squared. That is negative 2 times 4, which is negative 8. So our last point is at 2 comma negative 8. Now that we have all 5 points, let's go ahead and graph them. Negative 2 comma negative 8, negative 1 comma negative 2, 0, 0, 1 comma negative 2, and 2 comma negative 8. Notice how our parabola opens down. So the reason why our parabola opens down instead of up is because our a value is negative. Now if it was positive, then the parabola would open up. Let's go ahead and write down our key features. We know that the vertex is at 0, 0. We also know that the vertex is our highest point, and as a result, our maximum y value is at y equals 0. In regards to the domain, your domain is going to represent the x values. Okay, so if we look at the graph, we have to determine where our x values begin. I like to label my x-axis. I know that everything on the left side is going to be negative infinity, and everything on the right side of my x-axis will be positive infinity. That's because all the numbers on the right side are positive numbers, and all the numbers on the left side are negative. To find the domain, I like to look at my endpoints. Notice how at the end of our graph, it shows that our graph goes all the way to infinity. If we were to pick a point along infinity, we know that this point, it could be anywhere on the parabola, we know that this point is going to have a negative x value and a negative y value. That's because we're in the third quadrant. Now, if we look at this point, we know that this point is always going to have a positive x value and a negative y value. And that's because we're in quadrant 4. So now, when we're looking for the domain, we have to figure out where x begins. And x begins at -infinity, and it ends, once again, we're looking at x. It begins at -infinity, and it ends at +infinity. Another way to write -infinity to infinity is by writing all real numbers. And that's our domain. For the range, we need to look at our y values. What's the lowest y value? Well, if we look at the ends of our graph, notice how it's unknown what the lowest y value is. All we know is that this y value is negative. So the lowest y value is -infinity. The highest y value is going to be our maximum. And the highest y value is 0. I am going to put a bracket around 0 because 0 is a part of my graph. Whereas infinity can be any number. So I put parentheses around the infinity because we don't know what that number is. Another way to write the range is by stating that y, so put or, so y is less than or equal to 0. So in other words, our y values are all the numbers less than or equal to 0. Explain to b. Graph the function, state the domain and range. Our a value is a fraction. When we use a table to graph, we want our x values to be multiples of whatever the denominator is. The denominator is 2, so our x values are going to be multiples of 2. Based off the equation, I know two things. One, I know that my parabola is going to be wide. And that's because a is -1/2. I also know that the parabola will open down. Let's go back to our table. Y equals -1/2 x squared. And our third column is going to be reserved for our point. Let's start off with -4. When x equals -4, y will equal -1/2 times -4 squared. That's -1/2 times 16, and half of 16, so -1/2 times 16 is -8. Our first point is at -4, -8. When x equals -2, y will equal -1/2 times -2 squared. That's -1/2 times -2 squared is 4. And -1/2 times 4 is -2. -2, -2. Our third point is going to be when x equals 0. When x equals 0, y will equal -1/2 times 0 squared. That's -1/2 times 0, which is just 0. Our third point is 0, 0. For our fourth point, we're using x equals 2. When x equals 2, y equals negative 1/2 times 2 squared, which equals negative 1/2 times 4. Negative 1/2 times 4 is negative 2. So 2 comma negative 2. And I ran out of room, so I'll continue my table on the right side. So when x equals 4, y equals negative 1/2 times 4 squared. 4 squared is 16. And negative 1/2 times 16 is negative 8. So our fifth point is at 4 comma negative 8. Now I'm going to highlight all my points. I have negative 4 comma negative 8, negative 2 comma negative 2, 0, 0, 2 comma negative 2, and 4 comma negative 8. Let's plot them. Negative 4 comma negative 8, negative 2 comma negative 2, 0, 0, 2 comma negative 2, and 4 comma negative 8. Your points should align and everything should be symmetrical. If they don't align, you probably did something wrong. Draw the curve, label the graph, g of x equals negative 1/2 x squared. Let's go ahead and label the key parts. We have our vertex, which is at 0, 0. X is 0, y is 0. Our vertex is also the highest point, and so our maximum y value is at 0. For the domain, where do our x values begin? Well, if we look at the ends of our graph, we can't really pinpoint where our x values begin. So I'll put negative. We know that our x value is negative, and we also know that our y value is negative. And for the right end of the graph, we know that our x value is positive and our y value is negative. So where do our x values begin? Well, it starts with negative, and because we don't know what it is, that's going to be negative infinity. We don't know where x ends, but what we do know is that x is positive, so we're going to put positive infinity. Or you can write it as all real numbers. So the domain is negative infinity to infinity, or all real numbers. For the range, we need to look at our y values. So the lowest y value is unknown. Our lowest y value is at negative. We don't know the exact number, so we'll put negative infinity. And we know that our highest y value is at 0. Bracket on 0 because 0 is included in the graph. Another way to write negative infinity comma 0 is by stating that all the y values are less than or equal to 0. And that's how you find the domain and range given a graph.